Hello, everybody. Welcome to this podcast episode of the Sustainable Space Economy. The Sustainable Space Economy is an initiative that promotes responsible, sustainable practices within the space sector, focusing on social, environmental, and economic impact. The Sustainable Space Economy unites global stakeholders to foster collaboration, aiming to integrate sustainability across all areas of space development and operations. They offer resources like advisory networks, consulting, and certifications to encourage industry-wide adherence to sustainable practices aligned with the UN Sustainable Development Goals. My name is Marcelo Boldt. I am a space engineer from Argentina, living in Germany. I spent the last 5 years working in companies or space agencies like the German Aerospace Center or DLR, where I developed structures for example, Callisto, which is a flight reusable demonstrator. Then I also worked briefly on IDEFIX MMX, a rover set to land on Phobos, the Mars moon. And nowadays I'm working as a structural design and mechanisms engineer at POLARIS Spaceplanes in Germany as well. Today's podcast episode is about artificial intelligence and AI for sustainable applications in the space industry. And before we start with the episode and I introduce today's guest, I want to say why sustainable is important for me. What I think is sustainable or sustainability could be taken as having the chance of doing things right, which I think that if we ever become multiplanetary species, the ability of being sustainable from ground zero, let's say, is crucial for our aspirations, but also for the generations to come. So today's honorable guest is João Montenegro. He is the managing director, I guess. You feel free to correct me, from Darkmatter. And well, João, welcome. Happy to have you here.
Thank you so much, Marcelo, and for the kind introduction. And I would like also to thank Sustainable Space Economy for the invite and the opportunity to speak here about this topic. So yeah, you're right. I mean, managing director is the way you put it. I am founder of Darkmatter, and my background is a bit mixed. So I've been working in both hardware, software, throughout my career. But mostly, starting a couple of businesses helped me a lot to really deep dive into the problems. I am, really passionate about trying to understand why things don't work and try to make them work. I guess that's the way of putting it. The rest is history. So my background, my training was actually in physics engineering and industrial design. And then I learned how to program while I was making my first startup. And eventually, delved into AI, and the rest is history. So Darkmatter, in a nutshell, we try to solve the hard problems with AI. We don't want to just to build, SEO optimizers with language models or, basic Instagram post builders. We're focusing on trying to, solve tricky things, because we believe that the purpose of AI should be to, make humans do better, make humans do more and better work, not the opposite. So yeah, in a nutshell, that's it. And I hope to tell a bit more, my ideas here throughout. So you said in the beginning what your vision for sustainable. I don't know if this is what we was going to ask later, but
I would like to hear you. I think if you can tell us what sustainability means for you, would be great.
Right. Fantastic. So I think you already put it pretty much bluntly. It's hard to beat that one. This one, we spoke before, and I kind of like this definition, which is sustainability is about survival. So it's kind of like an interchangeable idea of survival. So yeah, it's about doing things right, and it's vital. It's about keeping the future possible, making the future possible for our descendants, and also making the future possible for life on Earth, for the this little patch of of very, very amazing things that happen here on Earth, which should be protected, but is essential to survive. So yeah, I guess that's it.
I think survival is a very interesting way of phrasing it, or framing it at least. So yeah, let's see what we can achieve as a collective, as a whole, right? As a species in terms of sustainability. But I'm always positive about all the wonders we can do. One of the things I basically, and perhaps the first topic I want to talk about and to kick in this podcast episode is, I come from the upstream world. So for the ones who don't know what upstream is basically the manufacturing of components or tangible things, as you'd like to put. For example, telescopes, solar panels, satellites, rockets, all of that is part of the upstream. And well, usually, as well as people know, it's when they say it's rocket science, right? So rocket science and rocket design and satellite design are very complex and very nuanced, let's say, topics. Especially, you cannot achieve them perhaps with one person alone. So maybe we can start by talking about the usages of AI for this type of applications.
Right. That's tough one. So yeah, starting from the core, right, from the beginning. What we see, at least, and in my personal experience, framing a little bit again, this idea that AI is about empowering. Good use of AI is about making things simple, in my perspective. It's about making interfaces and making, software that can give better tools for the people that make the hard things happen, right? So if you're making a rocket, and as you said, it involves a lot of people collaborating on a lot of different information. Everything needs to fit in the end. There are many stories in aerospace where things didn't fit. And that's laughable, but whoever was in that project didn't laugh, I guess. So these days, I think that's one of the key things that AI really does well in the space of design. It's helping the engineers really digest all of that information, finding problems in the way things are written, seeing if things are like all the systems are compatible with each other, right? Mm-hmm. And ultimately helping the engineers think a layer up, right? Because what can happen a lot is being stuck in the details, being stuck in analysis, being like in this decision block. And if you can step back and let the AI maybe, do a lot of the work that you would be doing in writing and perfecting the quality of how things are written, how things are described when you're designing something, that lets you step back and ponder other questions, right? Like make bigger questions, like compare different outcomes, etc. And I think there's of course a phase we're in. AI right now, and especially these general models, have started to come in and making this type of exercise possible. But there's still a way to go, especially when you talk about more like particular areas of this type of work, like a simulation and design. And that's where I think the barrier is, and that's where what I'm really interested in. Really trying to see what's the role there of AI. It's not like AI is going to basically design everything by itself. There's going to be a lot of improvements of how we design things by using AI in the loop. And that's something that I see more as a two-sided things, right? Humans on one side and AI getting better at understanding design principles and objects and connections between parts, etc.
I think it's a very interesting point what you are exhibiting, let's say, or what you are basically presenting. When you're manufacturing something, because at the end of the day, you need to manufacture what you are designing, right? And it's clear that AI cannot replace that interaction we have with tools. Yeah, of course, the machines will, at the end of the day, like CNC machines will produce the goods that we use to send to orbit and whatnot. But it's clear that there is an interaction, an ongoing interaction there. Something that I could say perhaps partially agree with you is that, yeah, it seems that AI can actually simplify the interfaces, which is basically where the design of anything starts. But I'm really curious to briefly talk about, okay, what can AI do for manufacturing?
Right.
Maybe in a nutshell.
That's a good question. So, I mean, anybody that has worked in manufacturing understands that it's a very it's a multi-step process. There's a lot of different parts coming into place, literally and figuratively. From the design becoming, possible to make, from design to making it possible to make, there's a lot of iterations, a lot of steps that need to be done. From simulation to reality, there's also a lot of steps. There's definitely, a lot of benefits of coming in and, at the software side, using AI to do these kind of predictions, right? Because one of the things that kind of like explains well where we are, in the phase of AI is that AI has been born in the world of software, right? Language models, vision models, computer vision models, other type of thinking, let's say thinking models, right? Like they're born in the world of AI, of software. So passing them into the world of physical things is not easy, especially because the validation cycle is much longer. For instance, if you have a requirement for a spacecraft written, and the AI writes it in a different way, like a way that you see it's not correct, you can quickly, say it's wrong. But it's really hard to validate with the physical world, because that means you'll have to manufacture the thing and actually test it in real life. And then you can say to the AI, that's wrong. So that's where I think things are going to change more as we get better models, like faster models coming in. So one of the key things that's been happening in AI is that AI models are starting to become able to not only see images, but stream, so see video and hear audio. That means that they can start perceiving the world as we do, right? They can start perceiving the world not as like finite data set, tags, and optimization cycle, and that's it. It's more of a continuous experience of understanding, okay, that's an object from another angle. Can I project the object from the outside? Can now I think of the object moving in a room?
Yeah, so very interesting. That's very interesting.
So this explanation to like the purpose of moving it into manufacturing is that there's still steps there, but there's already a lot of information available for AI to kind of optimize value chains, for instance, which is very important for manufacturing, right? Yeah. So making sure you're buying the best price for that part, making sure that part matches well your design, and do this automatically is something that AI can do really well already.
Great.
So there's definitely many angles here, but
I see. I'm actually surprised to hear about this. I think usually kind of to summarize or wrap up this part, I think is let's put it this way. The common understanding is usually the AI comes and overtakes everything, but it seems that there is more to it, and that's a very positive thing to do, and to, let's say, as for us, at least for me as an engineer, is a very great scenario to play along. Well, maybe moving into the second part of the podcast, something that is perhaps a little bit more, how to say, a little bit more straightforward to imagine, which is AI in mission operations. So, yeah, there is a lot to it, right? So maneuvering spacecrafts, basically being able to compute or to estimate the best possible trajectory, or trajectories in such way that they need to use the least amount of fuel, and also will create the least amount of space debris. I mean, like all of those perspectives and variables are something where the application of AI is much more straightforward and easy to visualize. So, yeah, I wanted to bring a discussion on this topic with you and see where we currently stand up.
Right. I think like one important thing to highlight in this kind of definition of artificial intelligence is that usually the definition is it's tricky. So sometimes people call or name artificial intelligence to the algorithms you just mentioned, right? You can almost sell like these complicated algorithms for predicting orbital positions or predicting collisions as artificial intelligence. You would do this in the past in many ways, right? It's a branding problem, right? But it's also the reality of the word, because the word is very difficult because of the second part of the word. The first part, artificial, is easy. Second part, intelligence, is really hard. We don't really know how to define intelligence. It's really difficult, and it always changes. And as we understand better intelligence, that definition moves around. So one of the key things to highlight is that the big changes in the last perhaps like 3 years or 4 years is how artificial intelligent models, so models that learn, that improve, that are not depending only on the programming of their original designers, but that change over time with more information. These models are becoming so good at understanding context that they can now use the tools, these more narrow tools for prediction, or these more narrow tools for control, that humans would be the only ones that could program in the past, but now these models can actually control them. The very interesting highlight here is that, for instance, if you have a spacecraft in orbit and you would just want to, and you already know exactly what you want to do with it, you have the mission really well outlined and you want to execute it, there's a million algorithms out there that do the job really well, and you don't need to call them artificial intelligence. Where artificial intelligence comes in, which is a really interesting opportunity, is in autonomy. Is in putting a little brain on top of the spacecraft, basically thinking about it as a little brain that can look at all of the dials that it can pull, and if something happens, it will outline a plan of which dials to pull to change the mission parameters, perhaps, to predict a series of outcomes based on the tools that it has, and eventually even to execute and make decisions. How much autonomy we want to build in really depends on how comfortable we are with the performance of that AI system. But think of it as something that a layer of intelligence that we put on top of an existing system. It's not to replace the currently existing algorithms that control spacecraft or predict their positions. It's something on top of this. And it's not something that is aimed to really replace the humans when you can have humans, because when you can have humans, at least for the foreseeable future, in these scenarios, they are the ones that are going to make value judgments, and they're going to make something that, decisions that are based on their reality, their lived reality.
Correct.
It's hard for AIs to really do that. And it's a bit beyond the point. What humans will do with AI will be something like command the AI, tell it to do a very complicated task. Tell it to do, for instance, multiple mission parameters. Compare multiple mission outlines based on changing scenarios. So something that you in the past would have to do, like with a lot of human resources and a lot of different studies, you can now do in a quick relative sense, but you can do it faster and faster, right? The AI can run, maybe 10 scenarios or 20 scenarios at the same time, where unpredictable changes are done to the whole mission. For instance, you can say, okay, something might happen during this process of the mission that we haven't programmed yet. You don't have that simulation yet. The AI can actually come in and create that simulation. It can create code that simulates this new possibility, maybe like micrometeor, colliding with your antenna at some point, and create a random value. And then you can ask this question without having to think of all the parts you need to build before you ask it. So the AI kind of works as a sidekick here that understands the physics, can manipulate the software, and can help in answering your question. But just to highlight one more thing is that cool thing that's happening is that these AIs are getting so fast that you can, and so small that you can now put them inside of satellites. You can put them definitely inside of drones right now. There's drones running LLMs. There are robots running LLMs already. There are, let's say, multimodal models controlling robots already. And the prediction of many is that this is going to have an impact in the future of how autonomy is done. So how
Yeah.
spacecraft actually fly themselves.
Wow, that's very insightful. That's very insightful, because nowadays you have these gigantic, let's say, control centers, like the ones you find in the south of Germany, or the famous one, perhaps the most famous one, Houston, where they have like extensive human resources to basically control satellites or missions for that matter, right? So I'm actually, I would kind of hold a wild card there, because I don't know how it's going to evolve and unravel in the future. But I am certainly interested in see how it goes. Um, I would like to actually talk now about our last topic for today, which is the, let's say, the AI for space insights. So, to give a short introduction to our listeners, yeah, there are increasing amount of data in space missions that basically generate, and they are growing exponentially. And AI will certainly play a role in this, in this type of paradigm and landscape, because it can analyze and process data in a way that humans can't, and can serve humans to do such thing. So, Joe, what is your take on this, and what can you share with us about this?
This I would say is the bigger area that's going to grow fastest, also soonest. We talked about before autonomous spacecraft. I think it's going to take a while. What's going to take what's going to be really fast is the way that we put compute in orbit, right?
Yeah.
You just mentioned like the ground stations, right? These big centers that receive information from space. They're proportional in size to the lack of, let's say, compute power you have in space. Just to make an example, if you have a space mission that has to optimize the mass of your, onboard computer because, and the power of your onboard computer, because the batteries cannot be too big, because the solar panels cannot be too big, because this is all connected. So if your system needs to have this constraint, it means you cannot really process a lot of information. That means you need to send a lot of data down to Earth, because the processing will be done on Earth, right? This has been kind of the tradition of space, to have what we can call embedded electronics in space, and then computation on Earth. And what's curious about the first segment, which is the change for the space segment, of the first part of the question, which is the change of the space segment, is that we're seeing now more and more people moving compute into space. Because, first of all, computing is becoming more and more efficient. So you can put it in a place where it's light enough and not consuming power enough that it makes the mission unviable. And the second thing is that the algorithms that process process data, are becoming so efficient that it can run them on really like smaller computers. And these two things mean that instead of basically communicating with a satellite and saying, okay, send all of the data you recorded in orbit in the past, X amount of days, you can actually ask it a question, like say, did you find this vessel? Did you find any alert on this location for a forest fire? And the satellite will just send you the location. It will not necessarily send you for instance, one thing which I heard many times before of EO observations is that the amount of data that's sent for blue ocean, that's just sea, that's perfect. You don't need to see. It's like, 2/3 of the world is blue ocean, and most of the time you're looking for something else that's not in the blue ocean, or like a ship that shouldn't be there, right? But most of your image will just be a blue ocean. So with the amount of energy and of time that is spent sending just those type of images that are not really useful is enormous, and it's a bit of waste. And that means you can focus more. And if you don't do this, you can focus more on having onboard computing that is actually providing products and not just data. So that's one of the things. It's like the segment. from space, how it changes, and that's going to keep changing. And that some companies are even investing in billions of dollars in making compute centers in space, like these edge computing, basically data centers in space that can process a lot of data for other spacecraft before it goes down to Earth. And then there's the other angle, which is how you search that data, how you interact with that data. Like sometimes humans have a hard time asking questions, right? Like, what is it that you're looking for? And that's something that's the first thing to change, right? That's how AI really is changing things, like making the whole Earth a search engine, right? You can basically search any image on the surface of the Earth, which is something that some companies are doing, which is quite interesting.
Well,
so that's two angles. Yep.
Yeah, I have to say that's very, very insightful. Because from my, let's say, again, as an engineer and not in that field, it looked like to me that the AI will actually play a crucial role in this sense, or in this specific thing, like space insights. But actually, it's interesting the way you put it, because the way we interact nowadays with ChatGPT, where we basically ask ChatGPT to basically answer questions for us from all sorts of let's say, doubts and activities, can also be applied to the let's say, to space operations. So a space ChatGPT would probably or perhaps come up soon. So that's quite nice. Well, I want to wrap up and kind of give a short summary of what we discussed today. So, to my surprise, João actually brought a very interesting point of view on AI. Which basically AI is a collaborative tool, or perhaps the perfect collaborative tool, because it not only allows us to bring something that is very complex and very hard for us to basically solve on our own, to more simpler and easy terms to understand, and being able to actually produce actionable decisions and perhaps even improving our decision making. But it also brings a lot of substance and a lot of potential for growth in areas where, well, we need to actually anticipate ourselves for a certain situation, right? So what you were basically mentioning on, okay, if I have a spacecraft and I need to be able to run, let's say, 10 scenarios where this or that, A, B, or C can happen, what are the odds of doing that? And the same goes to Earth observation processing. So I have to say, it is nothing short of exciting to see how AI actually comes into play in the space industry, and how it's going to look from, let's say, from today to 5 or 10 years. So, João, thank you so much for sharing all your knowledge with us. I hope you had at least as great of a time as I did, and yeah,
definitely
looking forward to hear more.
Thank you so much for the opportunity, and I think this, as you said, this is a really exciting moment in time, because we're looking at the next generation of toys, of tools we can use. Really, we had a lot of tools in the past from different generations, and this is really a new generation of tools. Instead of hearing the AI hype, which is it's going to steal your jobs, or it's doing this and that, which is, I think, it's just media. So yeah, looking forward for any follow-ups that came from this, and it was really great being here.
Awesome, thank you so much, and thank you for everybody, and to everybody who was today listening to us. I hope you got a lot of insights and a lot of value out of this conversation, and well, stay tuned for more podcasts on the sustainable space economy. Thank you so much. Bye bye.
Bye bye.